Okay, the half-life of a positron is very short. It reacts with an electron, and the masses of both are converted to 2 gamma-ray photons. This reaction is called an annihilation reaction. That's kind of scary sounding. The mass of the electron or positron is very tiny. Calculate the energy produced by a reaction between one electron and one positron. So this is the same thing. I just gotta.
Yeah, except there's one extra equation down there. I actually don't know where this equation is. I looked over chapter 18 everywhere and I couldn't find the bottom equation. But the top equation is just like we did.
Okay.
Basically, we have the mass, and it's going to be converted completely to energy. So we go back to Einstein's E equals mc squared for this. Where we have an electron and a positron colliding to form gamma rays. Oops, that's wavelength. So, what we do here is we add up. Well, I guess you tell me what we should do here.
We're supposed to do the same thing where we add up, but don't we have to know like the standards for what those guys are? So the mass of electron or a positron. Oh, okay, so those guys are both 9.91.
Yeah.
Okay, so you have 9.9109 times 10 to the negative 31 plus that same number times 10 to the negative 31st. Then what's the gamma ray going to be for its energy?
It's just energy. So we set up this equation. This is what the gamma ray will be.
Okay.
This will be its energy in joules. Yeah, we don't need to divide by 2. Okay.
In the 31st.
I'd say be careful with that geometry, just if they're asking for like 1 gamma rays, how much energy 1 gamma ray would have.
That's be negative 2.
Yeah.
Okay, so that gives me 8.297 to negative 61 is equal to my energy.
That's not right.
No?
No, because that's
I gotta add them, that's right.
add them, and then you times them by this twice. So multiplication is just shorthand addition, right? This is shorthand multiplication. So it sometimes can be easier to just enter this in this multiplication twice.
Oh, you already have it plugged in for me, I see.
Yeah.
Oh, okay, I see. I was like, where's that part coming from? Okay.
Yeah.
So like 2 times 9.109 e to the negative 31st, and then times that by the speed of light squared. E8 squared.
Yeah, one way to minimize errors on your calculator, just from your calculator being a calculator and not a human being, is just multiply by this twice. It'll kind of stop the squaring from squaring anything but what you need to square. But it looks like it did it right the first time, so it should be okay. You grab the answer instead of the other one, so.
Okay. Well,
but it looks like it's okay.
Okay. 1.6287. 1.628707 e to the negative 13th. Okay, that's for my first part?
Yes. The second part is that they want to know the wavelength of the gamma radiation. Or no, not the wavelength, the frequency of the gamma radiation.
We're trying to calculate the frequency of joules? Is that what it is?
Calculating the frequency of the gamma rays produced. The way you can do that is, basically frequency is kind of analogous to energy. The higher the frequency, the higher the energy of the wave, because you have to put more energy in to kind of like whip a rope more. The frequency is how long it takes for a cycle to complete.
Here's this, E equals HV.
So Planck's constant, there you go.
I remember that in last semester.
H, V, V is frequency, this is Planck's constant.
What was Planck's constant again?
I don't know. If you still have it in your history, it was on that one website, chem website we dug up.
Oh, that was the 6.626. 6.626 times 10 to the negative 34th.
All right. Did you say 34th or 24th?
34th.
Okay. And we're looking for the frequency. All right.
Oh, okay. Well, that's not too bad if it's set up like that. So I got 2.458 to the negative to the 20th.
Yeah, which would make sense. Gamma rays have a super high frequency. So provided we've got the right constants from that website.
Guess we'll see.
We'll see.
To the 20th. But it could be
Okay.
2.4.
Don't forget the 2 photons are, the 2
So I need to times it by 2 or something?
divided by 2.
Oh, so I
Yeah,
didn't
because
have.
only half of the energy goes to each photon.
So divide that answer by 2 and I'm good?
Yeah, you should be.
So 1.22.
I wasn't sure if it mattered or if it would. Sorry.
No, it's fine. One thing that really stuck out to me is when I had you a tutor once, he said it's almost kind of better when you get them wrong,
Yeah.
because then you actually learn to go back over them. And you gotta think a bit
Okay,
about
cool.
what you did.
All right.
Cool, we figured it out.
Not bad. Not bad at all.